Next, please turn to page 5 of chapter 35. Let's consider the formations of nitrogen dioxide. Do you remember what is the definition of the heat of formation of nitrogen dioxide? Heat of formation, or you may say it is called the enthalpy change of formation of NO2. Do you remember what is its definition? Is the enthalpy change when 1 mole of nitrogen dioxide is formed from its constituent elements in their stable physical state under standard conditions. This is the definition. Now let's write down the equation. Formation, that means NO2 is the product from its element. Remember, keep this coefficient 1 according to the definition. Its elements are nitrogen and oxygen. Now balance the equation. Now bear in mind 1, so you need to write down half, and then 1 O2. This is the standard enthalpy change of formation of NO2. Now again, direct determination of the standard enthalpy change of formations of NO2 is difficult because N2O2 react to form NO. That means there are side reaction. The most obvious one is N2 react with O2 at very high temperature to form NO, instead of NO2. Okay? So it is difficult to determine this enthalpy change directly. Then how can we determine its value? By using Hess law. This is, maybe I label it, follow your textbook, it is root A. Root B, let's talk about root B. The first step is react N2 and O2 together to form NO. The second step, NO react with O2 to form NO2. Balance this equation, okay? Two and 2. Do you understand? And the enthalpy change for the first step is 180 kilojoule per mole. The enthalpy change for the second step is negative 1120 per mole. Now, how to relate these two equations together with root A? I show you all the methods, okay? I show you method 3 first. That means by summation. Now this is the first step. With delta H plus 180 kilojoule per mole. This is the second step. With delta H2 equal to negative 102 kilojoule per mole. Sum them up. Can you see that? 2 NO2 on the product side, 2 NO2 on the reactant side. Cancel them out. N2 plus 2O2 is equal to have delta H. Simply sum them up. Minus 112. 84. 68 kilojoule per mole. Understand? And lastly, now look at root A. We need to divide the whole equation by 2. In dividing the equation by 2, you need to divide this enthalpy change by 2. Have plus sign kilojoule per mole. And then this is the standard enthalpy change of formation of NO2. Do you understand? Look at the literature data. It is equal to 34 kilojoule per mole. These two numbers are the same. This is from the data book, okay? This is from the data book. And then this is calculated by using method C, the third method. Can you see that they are the same? This is the first approach, the third approach, sorry, the third. Now I will relate them by using the first method first. That means by drawing enthalpy level diagram or energy level diagram. In drawing the diagram, bear in mind for endothermic process, you need to point it upwards. For exothermic, point it downwards. First of all, label the y-axis. The y-axis is enthalpy. Understand? And then the x-axis, actually it is meaningless, but I like to draw it as reaction pathway. Now this is the first root A, the first step of root A. We have half N2, and then it is an endothermic process. Draw it in the middle, half N2 O2 form NO2 with delta H plus 34 kilojoule per mole. I'm not going to write down the unit. I color it in red. Okay. Then how about root B? Root B. It is root B. N2O2. It is an endothermic process. Endothermic process, that means point it upwards. To form 2 NO. No, one only. One, yes. And then 1 O is left. Now, be careful. Look at this equation. We have 1N2, 1O2 to form 2NO with delta H plus 180. But now look at this equation. We have only half. So what is the enthalpy? Which is 180 over 2, 90. I color it in green. This is the first step of root B. And then the second step, we have 2NO, react with 1O2 to form 2NO2 with delta H negative 112. Negative, that means pointing downwards, okay? However, in our cycle, we need only 1 NO, half O2. Sorry, I make a mistake. I should put it down in this way, half O2. Now, because it is an exothermic process, so point it downwards, okay? And then with a number negative 112 over 2, which is 56. Again, I color it in green. For root A, the delta H is 34. Is that right? For root B, there are two steps. First step, second step. The overall enthalpy change is equal to 90 minus 56, which is also equal to 34 kilojoule per mole. Can you see that? They are the same. This is this first method, drawing energy level diagram. Bear in mind endothermic pointing upwards, endothermic pointing upwards, exothermic pointing downwards. And then method 2 is similar, but the only difference is that we are drawing a cycle, enthalpy change cycle. Enthalpy change cycle, okay? It's easy. Now, this is the first root. We have half N2 react with 1O2 to form 1NO, and half O2 is unreacted. This is root A. And then the second root, first of all, these two combine to form, oh, I make a mistake again, sorry. I start from this one first, okay? Half N2 react with O2 this is root A. I copy it down wrongly. NO2 with 34. I color it in red. Only one step for this root. For root B, we have two steps. First of all, 1NO is performed, and then with half O2 unreacted. Okay, can you see that? Half NO, that means only one N. We need only half O2, that means half O2 is left. This is the first root. We have 90, and then this is the second step of root B, have a value negative 56. Again, can you see that 90 plus negative 56 is equal to 34. I color these two in green so that you can see clearly. This is the root B, the steps for root B.